Hello, I'm Mr. Vosser and I'm a computing science teacher. I'm really looking forward to spending the time with you in this video looking at how we answer questions from the Software Design and Development unit as well as the Computer Systems unit. We'll be focusing on the questions that require short responses, so we'll be learning how to recognise those types of questions and the types of responses that would go alongside them. This will really help you when you get into an assessment or examination situation, because you'll be able to quickly recognise these questions and get those marks under your belt and in the bag. So you'll have more time available for the longer coding and complex questions that you'll also need to answer. Of course, if there's anything that you're not familiar with or the answers don't quite make sense, then please do go make sure you talk to your teacher or use other resources that are available online or other resources that your teacher has told you about to ensure that you've got that topic well and truly understood before you go into any assessment. Okay, let's get started. In this video, we are learning to apply our knowledge in answering short response questions for the Software Design and Development unit. We're also learning to apply our knowledge in answering short response questions for the Computer Systems unit. The Software Design and Development unit and the Computer Systems unit are two of the 4 units that make up National 5 Computing Science. To be successful, the first thing we need to be able to do is recognise the type of question that's being asked and understand the style of response that's needed to that question. We'll do that by looking at the keywords within the question and identify the bits that tell us what type of response is being looked for. We'll also need to be able to take our computing science knowledge and apply that to the question that's being asked to ensure that we can achieve the maximum number of marks that are available. In this video, as I've said, we're just looking at those short answer questions which have short, sharp responses. Here are some generic tips that you could apply to any examination, but I think it's really important to think about them in terms of a computing science context as well. So make sure you take the time to read the question and understand what you're being asked to do. So quite often there is information within the question which will help you problem solve the answer. So taking the time to understand any keywords, taking the time to understand all the information that's being presented to you is absolutely essential. Make sure as you're working through these questions, you're managing your mindset. It's going to be absolutely possible that sometimes there's questions that you don't really understand or you're not completely sure what the answer is. Well, taking that time to go through that question and understand what is being asked you will hopefully mean you can use your problem-solving skills to be able to work out the answer or something pretty close to the answer where you might pick up some marks. So keeping positive and continuing to have a go is really important. Of course, you've only got a limited amount of time in your assessment or your examination time, and making all of that time count is really important. Either spending the time methodically going through the paper and keeping to a time outline that you've set yourself, or using any spare time at the end to go back through your questions is absolutely critical. And finally, make sure you're keeping your answers really clear. Your teacher or the examiner will be marking your paper and they want to be able to easily identify what is your answer and potentially how you arrived at that answer. So making sure you've used a clear structure or you've clearly identified where you've answered a question. If, for instance, you've had a go and then you've decided to have another go and make some changes and you've arrived to a different answer. You can just cross things out by putting a single line through them. The examiner will look for the answer and identify it, but just try and keep everything neat and tidy. Avoid scribbling or anything like that in the exam. Okay, let's have a little talk about what's going to happen in this video. So I'm going to present questions to you on the screen. I'll read through the question and I'll just make sure it's fully explained before I pause the video. When the video's paused, use the time to work through your answers. Once you've worked through the answer, unpause your video and then come back and see whether we've got the same answer, and I will talk you through how I worked through to get to that answer. Where there's the pause icon, there's also a suggested time about how long you should take on the question. This is a notional amount of time just to give you a bit of a guide, but I would certainly try to stick to that time as closely as possible to ensure that you're having the right pace for when you are in your assessment or examination. This is the first question we're going to tackle today. It asks you to convert the following 8-bit binary number into denary. The number is 1101 1101. So you've been provided with an 8-bit binary number and you need to convert it into denary. You can see there's a space available. Use that space to show the process that you've gone through to convert that number. You should allow yourself about 60 seconds, maybe up to 90 seconds to be able to get this conversion done. Please pause the video now and give it a go. Okay, so hopefully you got on okay with this task. The first thing I would do would be to draw myself a table and put all the numbers that I would use to represent 8-bit binary into the table. Remembering, we start with the smallest units on the right-hand side, and each time they're doubling all the way up to 128. So that gives me the values of 1, 2, 4, 8, 16, 32, 64, and 128. I would then take my number 1101, 1101, and write that number into the second row of my table. So that would place a 1 under 128, a 1 under 64, a 0 under 32, a 1 under 16, a 1 under 8, a 1 under 4, a 0 under the 2, and a 1 under the 1. This then clearly shows me what the 1s and 0s are representing. I need to add up all the values of the 1s to be able to calculate what my 8-bit binary number is in denary. So in this question, I have 11, 14, 18, 116, 164, and 128. When I add all those numbers together, it gives me 221, which means 1101, 1101 is 221, and that's the answer I would need to write to get my mark. Okay, let's have a look at question number 2. A car sales garage requires a program for loan applications. The user will enter how much money they want to borrow and the number of monthly repayments. The user will then be informed how much they must repay each month. Using the information above, design a user interface for the program. So the question here has given us a description of a problem, and it's asking us to design a user interface for the program. So the user interface is what the program will look like for the person using it. I would suggest in an assessment or examination, because you're going to be sketching something out here, you might want to use a pencil with a pen to be able to label in particular pieces of information. This question is worth 3 marks. You should allow yourself 3 to 4 minutes to complete this question. Please pause the video now and complete the question on your own. Hopefully, you've had a good go with the question and you're ready to go through the answer. You've been tasked with designing a user interface for a car loan application. I've started by clearly identifying this is a car loan application program by putting the title at the top. While you don't get any marks for this, it does help set your user interface out nicely, and it's good practice to do. Where I pick up my first mark is by clearly identifying the amount the user wishes to borrow and where the user would enter that amount. So I've written amount to borrow, and then I've given some further details saying user enters amount to borrow here. You might wish to draw a box to represent that as an input, but how you design it is entirely up to you as long as it's clear for the examiner. The second input that I have put is the amount of time that they wish to borrow for, so the number of months. And then I've clearly identified again where the user would enter the number of months they wish to borrow the money for. So that's our first 2 marks out of the 3. They are both for receiving inputs from the user and clearly identifying where the user would enter that information. Our third mark comes from displaying an output to the user, and this is the amount of their monthly repayment. So that, of course, will be something that is calculated, and you could label that as a calculated piece of information if you wish, but just making sure you highlight where the information will be shown to the user on the user interface. You don't need to be writing any program code. It's just a design exercise to gain your 3 marks. 2 marks for the input, 1 mark for the output, clearly shown in the design here. Here we are looking at question number 3. The value 1876.2 will be stored in a computer system using floating point representation as shown below. And then we've got 0.18762 multiplied by 10 to the power of 4. Identify the mantissa and the exponent in the above floating point representation. So what we need to do is identify 2 numbers in our answer to be able to get the 2 marks that are available. So in maths, scientific notation, standard form, is a way of writing numbers, either numbers that are very, very large or numbers that are very, very small, that include a decimal value. Computers use something similar to this, and that's called floating point representation. So you can see here floating point representation, but you might be familiar with scientific notation or standard form from maths. That's because computer systems can only understand binary values, 1s and 0s. That means the mantissa and the exponent must be represented in binary, but for the purposes of National 5, we just need to refer to the numbers that you can see in front of you on the question paper. You don't need to convert anything to binary. So you need to know that a floating point number is made up of 2 parts, the mantissa and the exponent, and the mantissa will dictate the precision of the number. So the more bits you allocate to the mantissa, the more precise the number can be, i.e. it could be bigger or smaller. And if you want to store a large range of numbers, then you need to allocate more bits to the storage of the exponent, as the exponent dictates the range of numbers that can be represented. So all you have to do in this question here is identify which bit is the mantissa and which bit is the exponent. As this is a 2-mark question, I'd be allocating myself 2 to 3 minutes to be able to complete this question, to fully read it through and then write out the answer. Pause your video now and give it a go. The mantissa is 18762, and you can see I've highlighted that in purple. Now, if there was a number to the left of the decimal point, that number would also be included within the mantissa. But of course, when we write numbers, we don't have any leading zeros, which is why I've written just 18762 for the mantissa. So the mantissa is dictating the precision of the number. So if the number was bigger, for instance, it was 91876 decimal point 2, then I would need to have allocated more bits to be able to get a more precise number. The exponent is the power of value. So we can see here that it's a number 4. That's because the decimal point has moved 4 places to the left. If the decimal point was to move more places to the left, then the value would be higher. Because that would be increasing the range of numbers, I would need to allocate more bits to the storage of the exponent. But in this question, it's just a case of identifying the mantissa and identifying the exponent. So when you have that type of question, take time to familiarize yourself with the numbers that have been presented, identify the mantissa, write that number out without any leading zeros, and then take the time to identify the number that is to the power of 10, and then write that number as your exponent. Here we have question 4. A business wants to keep data secure that is being sent by electronic communication. State a precaution that could be used. So within the computer systems unit, you'll have looked at some methods of security. This is looking for a security precaution that you could use when electronic communication is being sent. Because it's electronic communication, we know that is going to be transmitted across some kind of network. Now, this is a 1-mark question, and you should be able to quite quickly identify and then state the type of precaution that could be used. So you'd want to allocate yourself less than 60 seconds to complete this question if you can. Have a go, pause the video, and then when you're ready, unpause so we can talk about the answer. Okay, so let's take a look at the answer here then. The answer is encryption. So the question is looking for the generic term, the generic precaution that would be used to be able to encrypt data so that when it's sent, it would remain secure. Of course, there's different types of encryption that your teacher may have taught you, but you just want to go for that generic high-level answer of encryption to get the 1 mark. So that should be a nice, quick, easy mark for you to gain in the exam or assessment. Let's have a look at question number 5. So question number 5 is asking you to explain why a fixed loop would be used when writing code. So we know, because there's the use of the word explain, that we're going to need to give a little bit of detail as to why a programmer would choose to use a fixed loop within a program when they're writing their code. And you can provide a little bit of detail there. There's no example required, but you can use a little bit of detail behind the purpose of using a fixed loop. This is a 1-mark question, so you'll need to take about a minute, maybe 90 seconds in getting the answer down on paper. Pause the video now and give it a go. Let's take a look at the answer to question number 5. So we want to explain why a fixed loop would be used when writing code. Well, there's a few ways we can phrase this, but effectively the program will loop a set number of times, repeating the same sequence of code. So you're trying to get across this idea that the program is going through line by line, and as it moves through that loop, it will keep repeating each of those lines of code a set number of times. You could also word that by saying the programmer knows how many times the sequence of code needs to be repeated. So you're just trying to get across this idea that you know a fixed loop has a set number of times that the code will repeat before it moves on to the next set of code. And when we're looking at repetition, this is one of our 2 types of loop that we need to know for National 5. So there's the fixed loop and there's also the conditional loop. The conditional loop keeps repeating until some type of criteria has been met, and then the loop will end and the code will continue running for the rest of the program. So keep your eyes open for these loop questions. The repetition and the reasons why we're using repetition just need to be explained clearly in the question to gain your 1 mark. Here is question number 6. The code below shows part of a program. The program calculates the total age of 100 people. We can see that this sits in some other code because the 3 dots represent that the program has continued before the code we've been given, and the program continues after the code we've been given. So we can see here we are just seeing part of the program. The program code reads, for loop from 1 to 100, do receive age from keyboard, set total to total plus age, end 4. And then we would know the program would continue. The question then asks, state the standard algorithm shown above. So this is a 1-mark question asking you just to state what standard algorithm has been used in the code above. It's a 1-mark question, so you should look to take about a minute to read through the question and then identify the type of standard algorithm and then write that down. Pause the video now while you do that. So in this question, we've been given some code, and from that code, we're trying to identify the standard algorithm that's been shown, and then we're just writing that down to answer the question. So the standard algorithm is a running total within loop. Let's have a look at how we got that answer. So focusing in on the code, we can see here it says for loop from 1 to 100 do. So we know this is a fixed loop. So we know if we're being asked for a standard algorithm, we're going to probably have the word loop within our answer. Looking at the code here, we can see we're receiving an age from the keyboard, and we know because it's in a fixed loop and we can see that fixed loop is happening 100 times, we know we're going to receive 100 ages from the keyboard. We can then see we've got a variable called total, and we're setting that total to total plus age. So if the first time through we received an age of 20 from the keyboard, we would set the total, which we're assuming is set to 0 plus 20. When we go through that a second time, let's say the received age is then 15, we would have a set total to total, which is currently of the value 20, and then we're going to add the age, which is 15. So we would go 20 plus 15, giving us a new total of 35. And we can see that this would go through 100 times. So this total is a real clue that being added up each time it's going through the loop, that this is a running total. And we can see that's a running total within a loop. There's a set number of standard algorithms to learn as part of the National 5. It's just a case of familiarising yourself of the purpose of each standard algorithm and then being able to identify it in the context of the question. And one of my top tips when I started the presentation was about taking the time to closely read the question and to study all the different components of it, both the stem at the start, giving you a bit of description, the code or other information that you've been provided, and then the question itself. And putting all those pieces together might help you either find the answer or get very close to it. So do feel comfortable taking the time to break each component of the question down so you fully understand it, even though you're doing this against the clock. This is question number 7. The rectangle below is stored as a vector graphic. State one attribute of this object. So we know when we're talking about vector graphics that we have different shapes that can be represented by the code that's used to create the vector graphics. This code contains attributes of the object which give the computer information about where and how the object should be displayed on the computer screen. You're being asked here to state one attribute of this object. It's a 1-mark question, so it's going to be a short answer, and we should be looking to take between 60 and 90 seconds to get this done. Pause the video now to have a go yourself. In National 5, you could come across several different common types of vector graphics. It could be a rectangle, an ellipse, a line, or a polygon. So a polygon is an object that has at least 3 sides and allows for a wide variety of common shapes. A rectangle is actually a type of polygon, but given its frequency, it's often used, it's got 4 sides. An ellipse is like an oval or a circle shape, and a line object allows for the creation of lines. You just need to identify some of the attributes of the rectangle that's been drawn for you in the question here. So the attributes could include the coordinates, the fill color, the line color, or the line weight, sometimes referred to as line thickness. So the coordinates are used to identify the position of an object on the screen. Most shapes will make use of at least 2 coordinates, and that will be an X and a Y coordinate. In most common graphic formats, say something like SVG, which is a scalable vector graphic, the default starting position of the X and Y coordinates is in the top left-hand corner of the screen. In terms of the fill color, this is the color of the shape. So in this example here, the fill color would be white or transparent because we might not be able to identify whether or not there has been a fill applied. You can also set the attribute of the line color. So you can see we've got a line color that's black in the question here. And you also have line weight. So that is the line thickness. When you're setting the fill color or the line colors, there's different ways depending on which type of vector graphic you're using. So it might be saved by naming the color. It could be saved using an RGB color code combination or by using a hex code. The line weight is likely to be the number of pixels needed in terms of to draw the thickness of the line on the screen. This question is only asking you to state the attribute of the object, so coordinates, fill color, line color, weight, not the properties that would be stored with it. For example, fill color white, line color black. You don't need that level of detail. You just need to state one of the attributes. Moving on to question number 8. The programming language uses the len function to find the length of a string. Set name length to len in brackets name. When coding, a programmer types pen instead of len, leading to an error. State the type of programming error and describe its effect. So in this question here, we've been told that there's been a programming language making use of the len function, and that len function finds the length of a string. So that information has been given for you. You've then got a line of code where that's working in context. So we've got set name length. Name length is a variable to len with name in brackets. So we know there'll be a variable with something stored holding a name most likely, and we're trying to find out its length. When coding, a programmer types pen instead of len. So we can see there the programmer has made a typing error as they've entered the programming code. We need to state the type of programming error by identifying it from the question description and then describe the effect it will have. This is a 2-mark question. We want to keep our answer nice and focused and tight. So we will do that by just writing the type of error and then a brief description as to what would happen. Being a 2-mark question, I would allow yourself 2 to 3 minutes to identify, state, and then describe your answer. Pause the video now and give it a go. Okay, let's go through the answer then. So we can see that this is a syntax error. The code will be expecting len as the function name for it to be able to understand what to do. If a program has some code which it doesn't expect because it's been mistyped, or an error has been made during entry, so the syntax is not correct, then this is called a syntax error. The effect this will have when the program is run will mean that the program will not run, or the program will report an error when it tries to run. It might be that the program stops or crashes at the point of the error. So you will just need one phrase to be able to describe this effect that the program is not running, it stops running, it crashes, or it throws up, it reports an error to the programmer or the user when the program is run. If you were asked a question to then say, what changes would you make to make the program be able to run successfully, then you would look to correct the syntax to change the error so that the program could run without reporting an issue. That's 1 mark available for stating the type of error, so syntax, and 1 mark available for describing its effect, the program not running, reporting an error, stopping, or crashing. Let's take a look at question number 9. Part of a program requires users to enter their age to determine if they can book their theory driving test. If you apply for your provisional driving license before you are 17, you will still have to wait until your 17th birthday before you can book your theory test. complete the test table below. There are 3 types of test: normal, extreme, and exceptional. And we've got 3 blank spaces that are looking for 3 inputs. So we need to identify a normal input, an extreme input, and an exceptional input. We'll look carefully at the question because it's describing to us what the program should do. And from there, we will identify the 3 types of input that could go into this program that would fit into the normal, extreme, and exceptional category. This is a 3-mark question, so I would spend a couple of minutes reading and interpreting the information, and up to a couple more minutes getting your 3 answers written down. Pause the video now and give that a go. So sometimes the challenge with these questions is to unpick the information that has been given to you already. So we can see here it's about provisional driving licenses and that you can get that before you are 17 years old, but you can't book a theory driving test until your 17th birthday, so you would need to be 17 or older. So we can see here the first piece of data that we've asked for is the normal piece of data. So a normal piece of data will be any piece of data that the program would expect to receive. So 18, 19, 20, 21, 22, 23, any number that is bigger than 17. The extreme test data represents that data that is on the boundary of being accepted by the program. So in this case, we can see here that it's referring to the number 17 because it's a 17th birthday before you can book your theory test. So the extreme value is 17. There are other number values less than 17 that would be accepted, but there's no indication to us on how the program would look to handle that information. In terms of exceptional data, you can see here that characters, special characters, and numbers all together in a string have been entered into the program. This is not what the program would expect to receive, and therefore it would likely crash or throw some kind of error or information box to the user that this hasn't been accepted. This would all depend on how the program has been written. Exceptional data for a short response question like this is any data that the program would not expect to normally be able to handle. So to recap, we've got 3 types of test data. We've got our normal data, what would be expected the program to be able to normally handle. We have our extreme data. This is the data on the boundary of what would be expected or on a boundary of a particular condition test. And then we also have our exceptional data, which is where the program would fail to run, stop running, crash, or give an error to the user, depending on how the programming language has been set up to handle that. Looking to question number 10 here, we can see part of a design for a program is shown below. We can then see a diamond shape with some text in it, some arrows coming off that for a yes or a no response, 2 rectangular shapes before they're coming back together to another diamond shape. This is showing part of a program, and it's identifying the graphical design notation shown above. So you need to identify the graphical design notation shown above in that question. This is a 1-mark question, so you should spend about 60 seconds looking at that question, trying to determine the type of graphical design notation that's been used and write that down. Pause the video now and give it a go. The graphical design notation that's been used in this example is a flowchart or flow diagram. There are 3 types of design notation that we need to know for National 5. That's pseudocode, flowcharts, or a structure chart. Pseudocode is a useful way to lay out a program in terms of looking at the program language on a potentially line-by-line basis, and it lets you detail what you want your program to do without having to worry about the particular syntax of your chosen programming language. We also have the ability to be able to look at the program by using a flowchart. And a flowchart shows what is going on in the program and how the data is flowing around it. Flowcharts can also represent everyday processes or show decisions that are taken and the results of these decisions. Flowcharts are usually recognizable by either the circular edged rectangles, the rectangles, and the diamonds used within it. The diamond shape explains where there's a choice to be made. We've also got our structure diagrams, and our structure diagram break down a program into smaller sections, and each of these smaller sections can be worked on at any one time. This can be really good for big projects when there's lots of people working on different aspects of code, and that code can then be brought together into one final program. What we want to do is make sure that we've clearly identified, using the correct terminology, whether our design notation is pseudocode, flowchart, or structure chart in our answer to make sure we get the 1 mark that is available. In this case, it's flowchart. Question number 11 is asking you to explain why it is important that program code is readable. So you will need to draw on your experience of writing code, and when you're writing that code, what strategies have you used to make the code readable, and why did you make it readable? And if you can remember that, then you'll be able to answer this 1 mark question to explain why it is important that program code is readable. It's a 1 mark question. Therefore, you'd look to spend between a minute and 90 seconds on considering your answer and getting it written down. Pause the video now and give it a go. So this question is asking you to explain why it's important that program code is readable. And readable program code really centers around making it easier for editing or maintaining code in the future, either by yourself or making changes by another programmer who will be able to come along and easily follow and understanding the code that's been written. So often programmers will work together and they will work on each other's code. So it's important that when code is written, it's easy to be understood by others. And there's a few techniques that can be used, and you don't have to reference these techniques in the answer to this question, but it is good to know what these techniques are, because another common question is, how would you make code readable? And so those techniques include internal commentary, using meaningful identifiers, using indentation, and also using white space. So briefly, those 4 things, internal commentary, let's take that first. That lets the programmer add in comments to the code that don't get run as lines of code. They're just like notes or descriptions that have been added by the programmer, which when another programmer comes along, they'll be able to read those and understand the information that's been coded into that program. If you've been using Python or seen the SQA reference language, you'll see that the comments have been in using the hashtag. But different programming languages have different ways to indicate internal commentary. It's also important that we're using meaningful identifiers when we're making code readable. So that would mean, for example, when you're using a variable name that clearly identifies what it's doing. For example, if I was gathering people's first names, I wouldn't just declare the variable name as data, because data wouldn't be a meaningful identifier. I would use, for example, a variable called first name, because first name would help other programmers identify what is being stored in that variable. So it's a good idea when using variables or functions or procedure names that are meaningful so they can be easily identifiable. The program can also be indented in the right places. So for example, if you're writing an if statement, you would need to indent the action that would be taken if something was true, else, and then we would indent again. Using indentation in if statements or using indentation with loops makes the code easier to read, and it also, in some of the languages, a requirement. So the syntax requires you to indent, otherwise the program will not successfully run. We can also make use of white space to make code readable. And just like indentation, white space just helps us spread things out, separate different subprograms, separate different functions, separate blocks of code into a meaningful order so that they can be easily read and understood when you're looking at the screen. And this saves us having lots of code all crammed together, which can become quite confusing. So for the purpose of this question, we want to explain how why it's important that program code is readable. And that's because it needs to be easy to edit or maintain in the future, either by the programmer or another programmer. But I've just spoken about some of the techniques we could use, which you might be asked to write about in other similar styles of question. And here we are looking at question number 12. State the function of a processor's registers. So we know the processor is made up of three components. The central processing unit, the processor, consists of the arithmetic and logic unit, the registers, and the control unit. In this question, to gain the 1 mark, you need to state the function of the processor's register. Because it's 1 mark, you need about 60 to 90 seconds to get it done. Pause the video now and have a go yourself. So the function of a processor's registers is to store data temporarily. The register's temporary storage locations are within the processor, and they can store addresses, data, or instructions. Now, the processor is the part of the computer that handles the instructions used to ensure that hardware and software respond as expected. So this central processing unit can handle millions of instructions per second, and the processors must be able to fetch, decode, and execute instructions from RAM, perform arithmetic calculations, perform logical operations, as well as control read, write, clock, interrupt, and reset lines. So the arithmetic and logic unit, the ALU, takes responsibility for the performance of all those calculations, performs comparisons on numerical values, and also makes decisions based on logic using the operators and or not, for example. All these calculations and logical decisions are handled by the ALU, the arithmetic and logic unit. And this processing is of real numbers as well. The control unit is responsible for managing all the lines, so the clock, read, write, reset, interrupt lines. And this is what ensures the fetch execute cycle is successful when the computer is running. This concludes all the questions that we have in this presentation. Hopefully, they've given you a little confidence boost, and they're going to help you pick up the marks from the questions which require quick identification and short answers to be able to demonstrate your knowledge of the computing science curriculum. It's really important to remember there's 2 other units of work within the National 5 Computing Science. That's the website design and development and the database design and development units as well. We've focused exclusively on software design and development and computer systems in the questions that we've looked at. There is also longer style questions within the exam paper or assessments that you might do. This is where several questions are linked together around the same theme or context, and this will dive more deeply into examining your knowledge and understanding of the computing science course. But many of the tips and approaches that we've looked at in this presentation are applicable to those questions as well. Well, that's us having been through all the questions. Hopefully that's given you a good idea about the types of questions that you might face in terms of the quick, short response questions, and you feel they're well revised. Make sure if there's anything that's come up that you're not sure of, that you're going back and you're checking back over your class notes, accessing help from your teacher, or looking online for other sources of help. It's really important that you've reached out and you've asked for help where you need it to make sure that you can do as much as you possibly can before you get into your assessment or exam. All that's left for me to do is wish you the very best of luck and hopefully catch you in other videos just like this in the future. Thanks for watching.